For percent error, probably the most important thing to notice is that in here it says this is the absolute value. So the accepted value minus the experimental, it really doesn't matter which way you do it, whether it's accepted minus experimental or experimental minus accepted. You have to realize that that is the absolute value, and so no matter what, you're going to put it as a positive number, which a lot of students, like on number 1, if they do 1.24 minus 1.30 like is shown, that would be a negative number. They'll put a negative percent error, and it's not, right? So you're subtracting the two values they give you. You're dividing always by the accepted value, right? That's what mathematics has told you you should get in your lab, right? Your experimental is you run a lab, and that's the actual numbers. You know, you run an experiment, a chemical reaction takes place, and you at the end find, oh, you have 1.24 grams of this, product that comes out of a chemical reaction. Well, you might have done something that said it should have been 130. Right, so this number is telling you what percent you're off of what you should have got, right, the 1.3. So once you do the subtraction and divide by the accepted, make sure you multiply by 100 and then use sig figs, right? Both of those numbers have 3 sig figs, and so my answer has 3 sig figs. This is 3 sig figs, and this is 3 sig figs, so this is 3. This is 4 sig figs and 4 sig figs, so this is 4 sig figs, right? Remember that this 0 here doesn't count as a sig fig because there's no non-zero numbers before it, right? This is 3 sig figs, 3 sig figs, and that 0 counts because it's after a decimal and a non-zero number.